Hello, everybody. My name is Thomas Cameron, and I am the Chief Architect at Red Hat for the Central Region of the United States. You are here, I hope, for Security Enhanced Linux for Mere Mortals. My background is that I've been with Red Hat for about 10 years. I am a Red Hat Certified Architect, a Red Hat Certified Security Specialist, Red Hat Certified Data Center Specialist, Red Hat Certified Virtualization Administrator, and a Red Hat Certified Instructor, which in layman's terms means I don't get out much. My contact information is up here. Please, I would love to hear from you. If any of you saw the keynotes, I would absolutely love to hear from you on social media. I'm Thomas D. Cameron on Twitter. Don't hesitate to drop me a line. Let me know what your experiences with Security Enhanced Linux are, as long as they're good. And I'm also Thomas at redhat.com. Yes, I've been here for that long. We are going to talk about a number of things related to Security Enhanced Linux. First, I will talk a little bit about Red Hat's background and history with Security Enhanced Linux. We'll talk about where it came from. We'll talk about the architecture of discretionary versus mandatory access control. I'm glad to see you too. We'll talk about how SELinux works, a little bit of the fundamentals. We'll talk about labeling and type enforcement and learn how to deal with labels. I'll go into a couple of real-world examples. These are things that I have done myself and messed up the way that my system worked, or that I've seen people do, and common complaints when folks call in and they're having problems with SELinux, you know, oh, oops, yeah, this is what happened and here's how you fix it. As I said, that's my contact information. You can also, if anyone in here is old school, IRC, I'm on Freenode and Pound.rel. I'm choir boy. There is a story about that. Ask me at the party tonight. They're apparently videotaping, so it may not be the best place to talk about it otherwise. You can also see, you can find a copy of this slide deck once I post it at people.redhat.com/tcameron. That's where all my presentations are. And this, of course, will also be available on the Summit website. So that's there as well. And I'm also Thomas.Cameron on Google Talk. So actually, before I get into this, show of hands. How many folks are here for their very first Summit? Awesome. Thank you very much for coming and welcome. That is amazing. That's fantastic. So let's talk a little bit about where SELinux came from and what Red Hat has been doing with SELinux. We've been involved with the SELinux project for a very, very long time. A lot of our developers, I'm not going to go into all of these names, but a lot of our developers have actually been called out by the National Security Agency for their contributions to Security Enhanced Linux. You can check out the NSA website to look at the contributions. And Red Hat has also been acknowledged as a corporate sponsor or corporate contributor to the Security Enhanced Linux project. So that's kind of gratifying. Now, SELinux was originally developed by the National Security Agency. It was a set of patches to the Linux kernel using Linux Security Modules, or LSM. It was released by the National Security Agency in 2000, and it was adopted by Linus in the upstream kernel in 2003. Now, I know that the NSA has done a couple of things lately that may make some folks a little bit questionable. Keep in mind that Security Enhanced Linux is 100% open source. It has been exposed to some very, very granular analysis by folks outside of the intelligence community. It is completely trustworthy, and it's really badass software, so you can trust it. Now, raise your hand if you felt like the 98-pound weakling when you're trying to deal with Security Enhanced Linux and you feel like you're getting sand kicked in your eyes. That was me. That was absolutely me. My first introduction to Security Enhanced Linux was back when I was at Bank of America. I was on the Linux engineering team at B of A before I came to Red Hat about 10 years ago. I spent weeks messing around with SELinux, and at the end of that period where we were going with RHEL 4, because you remember RHEL 4 was the first enterprise distro with SELinux, I was like, yeah, so this thing, no. So I get it. If you have been intimidated by it, you are absolutely, if you feel the same way, in the right place. So what is SELinux? SELinux is an example of mandatory access control. And by mandatory, I mean if you came from a Unix background, if you're an old Solaris guy or an AIX guy or HPUX guy, or if you're really old like me, a DGUX guy. Oh, come on, I usually get one person that's like, ah! Or SCO, that's a bad word. But if you come from a typical Unix environment, you're used to discretionary access control. And we've got the typical sort of ownership where the user that owns a file, the group that owns a file, and then everyone else is considered to be other. And users have the ability or discretion to set permissions on their own stuff. If I own it, I can change the permissions on it. So if you want to go to mod 777/home/tcameron, we will not stop you at all. We will absolutely give you the gun, and you know where your foot is. We recommend against it, but, you know, it's discretionary. And if you have root privileges on the box, you own the box. You can own it. With mandatory access control, there are ways to make that not happen. On a mandatory access control system, there is a policy which is set administratively. You can centralize, you can set your policy, and it's fixed, so you can't make changes to it, even if you are root, if the root user has had mandatory access control imposed on it as well. Even if you change the DAC, the discretionary access controls, that chmod 777/home/myname, even if you change the DAC settings on that, if there's an SELinux policy in place which prevents some process or some user from accessing your home directory, you will still lock them out. So mandatory access control is a good thing from a security standpoint. And these policies can be super fine-grained. In fact, they are super fine-grained. There are policies that are in place to determine access between users and files, between directories or with directories, with memory addresses, with sockets, even TCP and UDP ports can have policies set so that, you know, a process can't bind to the port, even if it's running as root. In Red Hat Enterprise Linux, you are typically going to see one of two policies. There is the targeted policy, which is default. If you just put in a DVD and click next, 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 or you do a kickstart and just leave the defaults, you're going to have the targeted policy. The targeted policy, what that means is there are policies in place for various processes on the system. You know, the web server and the DNS server and the even all the way down to like the web browser. Firefox has a policy associated with it. Thunderbird has a policy associated with it. Everything else runs unconfined. In other words, SELinux doesn't have a policy on whether things are going to be allowed or not. There is also the MLS, or multi-level, multi-category security. That's out of scope for today's conversation because this is, after all, a SELinux for mere mortals. But it can be super, super complex. Typically, your MLS policy is going to be used in really complex environments. Frankly, almost the only place that I see that being used is in the real scary government organizations with three-letter acronyms, TLAs, the ones that you don't want to get on the wrong side of. So how does SELinux work? You can determine what the policy setting on your system is by looking at a text file called /etsy/SELinux/config that is also symbolically linked to etsy sysconfig SELinux. So you can look in there to see what the default setting is, or you can use the SE status or the get enforce command, and this is what that looks like. If I just take a look at the etsy SELinux config file, then I can take a peek and see what the default setting right there is. SELinux is set to enforcing. If I run SE status, it'll come back and give me a fairly detailed listing of information about what version number of the policy it is and whether or not it's enforcing, what the default mode is, from the config file versus what the mode is right now. And if I just run get enforce, like if I want to check to see if SELinux is enabled in a shell script or something like that, and I just need a yes or a no, I can run get enforce and it'll either say enforcing, permissive, or disabled. Now, SELinux has two concepts, well, it has tons of concepts, but there are two concepts about SELinux that we really want to pay attention to. And those are the concepts of labeling and type enforcement. And let me talk to you about what that means. Files, processes, ports, memory addresses are all labeled with an SELinux context. For files and directories, these labels are stored as extended attributes on the file system. So you have to have a file system that supports XAdder, extended attributes. For processes and ports and things like that, the kernel manages those. There's a table, and I'll show you that table in a little while, that manages what the default settings for things like processes, port numbers, and things like that. Now, the labels are in the format of The SELinux user, not to be confused with the GCOS or Linux user. There are categories of users that, again, we're not going to really talk about because we don't care about when we're talking about the targeted policy. But it's user, role, type, and then optionally level. For the purpose of this presentation, we don't care about the user or the role or the level. Those are really used more for MCS, like I was talking about earlier, multi-layer security or multiple level security. What we really care about for today is just the type. Remember, labeling and type enforcement. Those are the things you really need to understand about SELinux to be successful. Now, what I want to do is, as an example, I want to show you a fairly complex service. Now, to be clear, I'm talking about Apache Web Server not because it's inherently insecure. It's actually pretty darn secure. But if you think about it, Apache can do all kinds of things on your system, right? You can set up Apache so that people can have their own individual home pages, so it can reach down into the home directories. That could potentially be a breach, right? Because home directories are potentially where people's sensitive information is. So but the Apache server is not insecure. It just makes a really good example. When I look on the file system at the binary that we use to launch Apache, the HTTPD process under under user SBIN, when I want to check that file's file context, remember those attributes stored stored as extended attributes, I will see that it's user SBIN HTTPD has the attribute of HTTPD executable type. Remember, type enforcement and labeling. Now, if I go look at the home directory, or I'm sorry, not the home directory, but the config directory for it, it's labeled HTTPD config type. So if I do an ls-z against that home directory, etc HTTPD, it's got the label, the SELinux label, HTTPD config type. If I look in the log file, the log file directory, HTTPD _log_t, or HTTP log type. Ditto for the system configuration, or the system content directory, var www.html. If I do an ls-z, HTTPD system content type. If I look at the shell scripts that are used to start and stop it under etc.rc.d and init.d, same thing there. They've got a label that's HTTPD initrc exec type. We seeing a trend here, kind of a pattern? The labeling makes sense. It's usually something that's at least a little bit intuitive. When you look at it, you can see that things are related to each other. Now, when the process is actually running, and it's in memory, the HTTPD process is in memory, I can do a PS-Z against it, and again, there's a type associated with that process running in memory, HTTPD_T. And if you look at the ports to which the web server can bind, right? Because when a web server comes up, it uses, what are the standard ports for web servers? Everyone knows this. 80 and 443, right? But there are some real common configurations beyond 80 and 443. Well, if I use, and I'm sorry, it's kind of an eye chart for the folks in the back of the room. Again, these slides will be available afterwards. I used the netstat command, and I used the Z argument, -Z argument, and I grepped out HTTPD. And you can see that the port to which it's bound has the HTTPD type label as well. In fact, if I use the SEManage command, which we'll talk more about in a little while, if I use the SEManage command and tell it to show me information about ports, so SEManage port -L to list, and then I grepped out HTTP, if I look at the HTTP port type, 80, 443, 488, 8008, 8009, and 8443. Because those are commonly used ports that Apache can be configured with, and other packages that we include with the distribution are sometimes configured to bind to those ports. So basically, it's just setting rules. These are ports that are available for the web server service. Now, if I look at the etc shadow file, notice the type there is shadow_t. So type enforcement is, well, it probably makes sense for a binary that's labeled HTTPD_type to interact with a file with HTTPD config type, right? That's kind of logical, right? The web server needs to be able to access its configs. Do you think it makes sense for the web server, HTTPD type, to be able to interact with something that's got a file label of shadow_t? Raise your hand, we'll all laugh at you. Yeah, there's always one in every crowd. So, does that kind of make sense? It's labeling and type enforcement. This type of process with this type of label can interact with this type of file, assuming that the labels are all similar and the types are set. Type enforcement is just the part of the policy. It says, for instance, a process running with the label HTTPD type can have read access, and you can get that granular, read access or write access or whatever, with a file labeled HTTPD config type. That's how SELinux works. How many folks walked in here going, oh, SELinux, gotta learn. SELinux sucks. Yeah. See, as soon as I say that, hands are all like, well, yeah, as a matter of fact. Yeah, pretty much. It's not as complicated as you might have once thought. Used to be a lot more complicated, but we've gotten a lot of tools in place to make it a lot easier, and we're going to get to some of those tools. You've seen me use the -Z argument in a lot of these commands, right? ls-Z, ps-Z, cp for copying things, id-Z, that one's kind of cool to look at SELinux identities, netstat-Z. -Z is your friend when you start exploring SELinux. It works with a whole bunch of commands. I don't even have a comprehensive list of all of them, but there are a lot of commands that take the -Z argument so that you can deal with your SELinux stuff. So copy-Z, make dir-Z, there's a ton of stuff that you can do there. Now, you can also use SELinux tools or SELinux aware tools like chcon, change context, or restorecon to change the context of a file. Contexts are set when files are created, just like ownership in Mac environments, mandatory access control environments. They're going to inherit the context of the parent directory. Remember that because it's important. RPMs can also set contexts. You can actually define the context that you want a file to be installed to the file system with using the RPM spec file. And ditto the login process. When you log in, whether it's through a Getty or through an SSH session, the login process will figure out what the context is going to be, and it'll then inherit. Now, I want to talk a little bit about file transitions. So normally, if a file is created under, for instance, etc, it'll get created with the etc_t label, which makes sense because it inherits. But you can set rules called transitions. For instance, if an application with a foo type label creates a file in a directory labeled bar type, you could actually set a transition that says, no, 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 no. When it comes from here and it's going into here, we're going to set it to baz type. So you can actually define rules that say we're going to create something that's not inheriting from the parent. A great example of it is the DH client process, the DHCP client process. When it's going to create like a new etcresolve.conf, for instance, normally that would just inherit the etc type label from the parent directory because it's under etc, but we have a file transition defined in the policy that says, no, 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 this is a special case. We need it to have a type of netconf type. It's a network configuration file. So that's what a transition is. So you saw me use SEManage. I can use SEManage port to show me all of the things that SEManage can do with TCP ports or UDP ports. But I can also use SEManage against logins. I can use it to manage users, ports, interfaces, modules, nodes, file contexts. I can turn on and off Booleans, which we'll talk more about in a little while. I can even use SEManage to change the state of SELinux from enforcing to permissive and back. And I can also turn on don't audit. And I'll talk more about some of those in a little while. So, okay, Thomas, that's great. You give me some theory. I understand all that stuff. But I'm having a problem. What happens if I get an error? Well, if you see an SELinux error, it means that there's something wrong. But turning off SELinux when there's a problem is like cranking the radio up when your car's making a funny noise. Oh, problem solved. Nothing wrong here. So don't just turn it off. It may mean that the labeling is wrong. This is the most common case. Something got mislabeled and you just got to fix it. It's super easy to fix, and I'll show you how in a little while. It could mean that the policy just needs to be tweaked. You're doing something that we have found over time that most users don't want to do, so we turn off that capability. You just need to turn it back on, for instance. There could be a bug in the policy. It happens. Okay, the SELinux policy is fairly big. So, you know, errors are going to creep in. We're all humans. We make mistakes. Oh, and I do want to say, don't file a Bugzilla report, please. Open a support ticket. There is no service level agreement associated with Bugzilla reports. Okay? So BZs are nice, but it's better to open a ticket so that we're accountable to you. And then finally, well, it could mean that you're being broken into, in which case, you know, man the battle stations. Now, you heard me talking earlier about Booleans. Booleans are just on-off settings for SELinux. What we've done is, over time, we've done a lot of analysis and got a lot of feedback from customers, and we figured that there are some cases that just don't make sense, and so we leave them turned off. And then some cases that everyone does it, so we leave them turned on. But basically, it's things like, do we allow the FTP server access to users' home directories? If a common configuration is that the FTP server allows access to home directories, but you know, sysadmins are making mistakes and leaving that stuff on, we will generally flip the bit on the Boolean to say, nope. But it also goes to some more esoteric stuff like HTTPD can use mod auth NTLM winbind, because we all want to authenticate against Windows. All right. To see all of the Booleans, you can do get SEBool-A, or all, and you will see page after page after page after page. There are literally hundreds of Booleans that can be turned on or off. So, and it's everything, it's all kinds of stuff that you can think of. Like, for instance, this one always gets me. HTTPD enable home DIRs. By default, it's set to off. And I'll show you an example of being stupid, because I've done it numerous times, and how that looks. And it looks like you've done some misconfiguration on the web server, and really you just need to go, nope, I want to turn it on. So there are tons of Booleans. I mean, you can see there's just page after page after page of them. To set a Boolean temporarily, you just say set SEBool, whatever the Boolean is, and then 0 for off or 1 for on. If you want to make that permanent, pass the -P argument to set SEBool. Now, here's where we get into some of the tips and tricks parts. When you are going to be developing SELinux policy modules, or just trying to figure out what it's doing and make sure that you replicate that into your production environment, install the SE Troubleshoot and SE Troubleshoot Server RPMs. They're going to drag in a whole bunch of other files, but essentially what that does is that'll talk to Audit D, and it will write your log files in human readable format. It's hugely helpful. So SE Troubleshoot and SE Troubleshoot-Server. And then either reboot, if you're a Windows admin, or restart Audit D. Restart Audit D, and that'll start logging. And that's just what that looks like. I took some screenshots. Yum-y install SE Troubleshoot and SE Troubleshoot Server. It'll drag in a whole bunch of other files, and then it'll be ready to go. And then restart Audit D, and you should be good to go. So let's talk about some real-world examples. These are things that, in most cases, that I've done. But I've also heard from other people that these are common mistakes that get made. So let's say that I've got a user, Fred, who wants to have his own home page in his home directory. He's going to create the home Fred public HTML, public_HTML, I should say, directory on a web server. So you do all the things as a good sysadmin. You go and you modify the httpd.conf, or you can go create a secondary file under httpd.d. You set it all up. It's good. You restart the web server. You've made the entry in there that says user dir public_HTML. We're good there. Fred makes the directory and changes permissions on it, right? Because you know how you've got to set other to have execute access to /home/username. So we jump through all those hoops. We set that all up. He logs in. He creates his public_HTML directory, so you know that it's owned by him, and he creates his fancy schmancy new index.html file there. You restart the web service, fire up the browser, and at this point, typically what I do is I start going through the logs, and I'm like, oh, what did I do wrong? So we check the usual suspects, right? We're going to check access_log and probably error_log. So, okay, let's look at access.log, and it basically just says, no, you got a 403. Well, okay, I knew that. So then we check the error log, and that's even Less helpful. Nope, sorry, permission denied to the ~fred home directory. So, great, thanks for telling me nothing, because I already knew that stuff. So now we take a look at kind of the third usual suspect, var log messages. And we look in here. Okay, hold on, before I show you this, SELinux is hard, right? This is hard stuff. You gotta be a real guru wizard to make this stuff work, right? Right? Okay. SELinux is preventing the HTTPD process from getting attribute access on the directory home thread. For a complete SELinux messages, run this command. Copy this command and then paste this command right here. I don't know, it's pretty hard stuff. Bad user, bad user. He said, or set and force 0. So, but what's really cool is we follow the directions. Literally, we copy and paste this text string with this UUID, and we find that there are two issues: user content and access to the home directories. So check this out. The SELinux is really hard. This takes a lot of skill to do. And it goes, hey, if you want to allow it, then you got to tell SELinux about it by changing this Boolean. And the way that you do that is you copy this command, that one right, the one, copy this, paste it to the command line, and go along your merry way. I don't know, this stuff's pretty hard. Yeah, so it says you can create a policy module to allow this, but in this case, it's just a Boolean. It's just something that got turned off. So, now it does say I can create a policy, or a policy module, I should say. We'll talk more about that in a little while. But like I said, you really don't have to do anything. But, oh, and I should say that it actually gave us two arguments. We can either, we need to set SEBool HTTP read user content, and then also there was another one that was hit, and that is the Apache web server by default is configured to not allow access to home directories. But literally, copy that, paste it to the command line as root, and it will fix your problem. So, we do that, we follow instructions and set the two Booleans. So I do set SEBool, and remember you got to do --P to make it permanent. So set SEBool-P, HTTP read user content 1, and set SEBool-P, HTTPD enable homeders 1. And voila, now we got the home directory. Oh, this stuff's so hard. SELinux sucks, it's so hard. No. People say this stuff's too hard. Pfft, not buying it. 5 years ago? Well, no, more like 7, 8 years ago, I was right there with you. I was. SELinux on RHEL 4 gave us kind of a black eye. Not because it was actually that much harder to do than this, it's just that it wasn't documented well, it was very new, and people are just like, ah! And they turned it off. So, how can I see what Booleans have been set? I have inherited a system. The last guy left, and I've taken over the, what do I need to do there? Look at the booleans.local file under SELinux targeted modules active. And it's just a text file. It's real easy. It just shows the Booleans which have been set. Now, I do want to point out that it says this file is auto-generated by libsemanage. Do not edit directly. You can edit it directly. Won't do a thing. This is just generated when you create a new policy module or when you rebuild the SELinux policy so that you can see it. This is just a human-readable, not informational file. It doesn't change anything, so don't monkey around with it. Now, note that when you use set SEBool-P and some other commands we'll talk about later, the entire directory SELinux targeted is regenerated. In other words, it is deleted. The old directory is nuked and a new policy directory is created. So believe it when it says don't edit it, it won't do anything. So I gave an example of this. I created a little marker file. I did touch marker. You know the touch command just goes boop, 0-byte file. And then I ran set SEBool-P. And then I said find everything under SELinux that's newer than that marker file that we just created. Poof, everything. So, and that's kind of cool. It literally rebuilds the entire directory structure when you're done. So, now, the following example assumes a completely fresh new installation, like ignore the fact that we made Boolean changes earlier. So now we've got a user. We had Fred before, we got Wilma now. You can tell when I grew up. She has created content in her home directory, and she is the web content author for your company. She's asked you to move it over to the website. So you being the good sysadmin that you do, she's made her content directory, and she's not a very sophisticated web developer, but you know, she's made an index.html file in her home directory. So like a good sysadmin, you move it over just like she asked you to do. So move/home/wilma/content/star into var www HTML. Yeah, I know we would not do anything that silly, but it's just an example. Bear with me. But then when you go to test, sure enough, what's that? Okay. Well, but typically, right, if you come from an environment where you haven't used SELinux, you're like, oh, you know what, I bet that's an ownership thing or a permissions thing. So you go to take a look at it, and oh, it's Wilma, maybe that's it. So you challenge it to root, and oh, I'm such a good sysadmin, I know how to get around the system, and you do, dang it. So checking var log messages again. This really complicated service, this SELinux hard stuff. Hey, dude, run this command right there. Copy that, paste it. Okay, we run that, and it comes back. Now, this time, we see a message that is actually a little bit confusing, and here's why. Because it says, hey, it's trying to access users' content, and so you might want to set the policy, the Boolean to HTTPD read user content. Wait, what? It's not, we put it under system. Oh, you start thinking about that. Oh, hang on a second. I think I know what it is. So I do an ls-Z, and look at the type there, user_home_t. So when it got created in the user's home directory, it got user home type labeling. We've moved it over, and we haven't told SELinux that Apache can access users' home content. And in this case, we don't want it to. We're not using users' home directory, so we don't want to enable that for SELinux. We moved it instead of copied it, so it kept its old attributes. To change the context, we can do a number of different things. The first thing that we can do, well, actually, the first thing we need to do is we need to figure out what it should look like. Now, I'm lazy. I'm the first one to admit it. I don't want to have to figure a whole bunch of stuff out. So I'm going to go look at a known good directory and see what the context there is. So I look at var www, and I see that all of them are set up as HTTP system content type. So what I can do now is I can use the chcon, or change context command against this. And here's the long format. chcon-u system_u-r object_r-t http system content_t /var/www/html/index.html. How many of you are horrible typists like me? I hate typing really long stuff. And invariably, when this is going on, you've got a manager looking over your shoulder, which makes you type even better. So remember that we don't actually care about the user role, or even the user type or the role. So the short form of this is chcon type HTTP system content type against that file. That's the quick way of doing it. You don't really have to do the other ones. You can if you want to. But I am lazy. I'm absolutely lazy. I just want to reference a known good directory. I don't want to have to jump through the rigmarole of doing an ls-lz or any of that kind of good stuff. So what I can do is I can do chcon --reference. And that basically says, hey, chcon, that thing over there, we like that thing over there. Make that thing over here, over there, like this thing over here. So chcon --reference, a known good directory, and then the file that we want to do that to, and ba-boom, that'll work too. I'm really lazy, though. I'm not kidding. There's an even easier way to do it. You can rely on us. You can rely on the policy authors and say, just set everything under this entire directory back to the way that it should be. We do that using restorecon, restore context. So I like this. Restorecon dash, I do the -v because I like to see what it's changing, so verbose. Restorecon -v, capital R to be recursive, and you just drop a nuke on that whole directory. Fix it. And you'll see that it reset index.html from the user home type to HTTP system content type. So restorecon-v capital R is your friend when you're having weird issues with SELinux. And there we go. Here's our cool website. The server's up and running. Life is good. RestoreCon uses information from the file_contexts file that lives under SELinux targeted contexts files. There are over 4,000 entries in that file. Changing it won't do you any good, so don't modify it directly. Your changes will be lost. I'll show you how to make permanent changes to what file context will be in just a few minutes. So if you look, I mean, it's literally just page after page after page after page after page after page, just tons of stuff. And it'll say, you know, /etc/gpm, and then that regular expression says that and everything underneath it. I'll tell you a hint. Remember this file, because when you need to go set up a new context later on, trying to remember the regular expression, the slash, or I'm sorry, the parentheses, / dot, asterisk, close parentheses, question mark, I go copy and paste. I'll show you. All right. So somebody else, so you've got a corporate standard that says, oh, no, we put all of our web content under /foo/bar. I run into this stuff all the time. You'd be amazed at some of the things people do. No, we're going to put it under opt or something, because they're old Solaris admins, and that's how they did it in Solaris, doggone it. And that worked so well for Sun. Ooh, yeah. So we're going to do something non-standard is really the point here. We're going to have Apache accessing a part of the file system that it doesn't normally know about. So being the good sysadmin that you are, you create the directory. There it is, make dir-p/foo/bar, and I see that the bar directory lives under /foo. You define the virtual site in the httpd.conf or in httpd.d/virtual site, whatever. So we've got a virtual host directive. We put it under /foo/bar. We've done all the things like given it its host name and all that stuff, so we know we're in good shape there. You create the index.html file. Again, not terribly sophisticated, but you know, this is my dummy host.example.com web page. We put it in the index.html file. We restart the web server, and everything looks good. Yeah, I know, it's a rel 6 screenshot. I haven't done the rel 7 one yet. It would be system control restart httpd.service if it were rel 7. So we do that, but again, when we test the page, well, wait a minute. This is a little bit different. I'm seeing that there is a web server running, but I'm not getting my index.html file. So what was that log file again that we checked for SELinux errors? Varlog messages. See, this stuff's so hard. SELinux so hard. No. Varlog messages. We take a look at it, and again, it says copy and paste this error message. So we do semanage-l, the error message. This one gets a little weird, though. This one does get a little weird. I'll be the first one to admit it. It says, hey, if you want to allow HTTPD to have get attribute access on that file, you need to change the label on foobar index.html. And so you need to use semanage fcontext-a-t file type to foobar index.html, where file type is gives you a long list. That is actually a very accurate error message. It's saying, hey, HTTPD doesn't have access to this because it's not the right file type, and it needs to be one of these. But the first time I saw this, I was like, ugh. So, but at the end of the file, I love this. It says, oh yeah, and after you use semanage fcontext, make sure you use restorecon. So make sure that you run restorecon. So again, hey, do this and then run this. Don't tell me it's too hard to use. So let's see, what was that directory again? Where do we want to set the file context? If we were going to reference a directory for web content, we might look at, did you say opt? Well played, sir. Well played. No, var dub dub dub, right? So I look in var dub 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 and I see what the contexts are. We really want to make sure that everything under /foo is going to have the correct context. So again, I cheat. I totally cheat. I go look under SELinux targeted context files, file underscore contexts, and the syntax for that regular expression. So what I do is I say semanage because we're managing security enhanced Linux, file context, or F context, we're going to add, so -A, type HTTPD system content type to foo and everything under it. That makes sense? SE manage F context, add type HTTP system content type to everything under that directory. Or, again, lazy sysadmin is the best because we automate everything. You can use the -E argument. So you can just say, hey, SE manage F context, add what this has to this. So everything, the context of var www to /foo. And then it will write that out to file contexts.subs under etc SELinux targeted context files, and you can see that we've substituted or added to the foo directory the same context as var www. Now, all we have done at this point is we have told SELinux, hey, the foo directory and everything under it should be labeled like this, like the var www directory. We haven't made any changes to the file system. Remember, SELinux attributes are stored as extended attributes on the file system. So what we've done is we told SELinux this is what it should be. Now we have to do restorecon to make it how it should be. Does that make sense? You see the difference? You set the policy in one place, and then you enforce the or you relabel the file system in the other one. So we run restorecon against it, and sure enough, it comes back and it says we changed default type to HTTP system content type for foo, for bar, and for index.html. Make sense? All right. So then we test the site, and sure enough, this is the dummyhost.example.com webpage. Everything's working like we expect. Now, policy modules. In the case that setting a Boolean doesn't fix things, you can create a policy module. In this example, and this is an old Rel 6.3 example, but it's a really fantastic one. For my home server, my home network, I decided that I was going to install Squirrel Mail. I installed Squirrel Mail, got it all installed, went to go log in, and wouldn't let me log in. I knew that I was using the right password and username, but I went and, because I used to deal with this stuff with SELinux before I knew about SE Troubleshoot and SE Troubleshoot Server, I went and I looked under var log audit, audit.log. Anyone explored audit.log? Does that not make you want to cry? Right? Look at the syntax on that. It's ABC denied name connect for blah, 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 blah. Yeah, set and force 0. And that's a good point, and I'll get to it in just a minute. So I look at that and I realize, no, oh, that's awful. So instead I go and I look under varlog, varlog messages, and it tells me to run that command, run the error message. Now, this is where one of the tips comes in. If you know you're having a problem, set SELinux to permissive, so set and force 0, or change the SELinux config file and reboot, if you're a Windows admin, and run your application through all of its paces. And the reason that I say that is, for a long time, I just really wasn't thinking. I was like, oh, I found a problem. And I would use audit to allow, or I would use something like that, and then it would just expose the next problem. And then I'd have to run audit to allow again, and it would expose the next problem. And it was a real pain in the backside. So instead, what you want to do is, you want to set SELinux to permissive, run your application through all of its paces. So in this case, I set and force 0. I configured my mail server, got it all set up, sent email, logged in as another user, received email. In other words, ran it through all of the paces that it would normally do during a day's work. You may want to leave this on for quite a while if it's an application that's going into production. And what I would do is eventually I would get a whole bunch of SELinux alerts, and I could figure out what policy module I need to create. So it'd come back and it'd say, SELinux is preventing the web server from doing name connect on a TCP socket. And it says you can run the SE module command to create a policy module. And the way that we do that is I grep HTTPD, or whatever the process is that I know is causing the problem, from the varlog audit, audit.log file, and then I pipe it to, here, you can say it now. Audit to Y is one, but in this case, audit to allow. And then I tell it, create a module called Squirrel Local. I personally always use the word local in my modules just so that I know that it's something that I created. If I worked at XYZ Corp, I might do Squirrel XYZ or something like that. Just do something that's logical and makes sense for you and your environment. And then, you run SEmodule-I to install the policy module. So audit to why is actually a really good tool for just looking at why, and it literally spits out human readable syntax saying, oh, we didn't allow it because it was trying to make this kind of a connection, or whatever the error message is. But SEmodule-I, we install that SELinux module, and it creates the policy. Now, it could have been fixed by a Boolean. I just wanted to show you what it looked like. All right, so that's what the config file looks like that it generates for you. It'll tell you that for type A, we're talking about HTTPD type, SMTP port type, POP port type, and then TCP socket name connect. And at the end of the day, this is what the module is doing, the SELinux module is doing, allowing the web server to connect over a TCP socket to the SMTP port. Now, I could have just used a Boolean for that, but this is a good example of what that looks like. So SEmodule-I, set and force 1, run it through its paces again, and make sure that it works. And sure enough, I tested it. To enable security-enhanced Linux, edit the SELinux config and set SELinux to permissive if it has been turned off in the past. Don't just turn it on enforcing. You will have a very bad day when you try to reboot if you just turn it to enforcing. You will get very, very cranky and say bad things about your parentage. So set it permissive, touch a file in the root of the file system called auto-relabel, and reboot. And it'll take about as long to relabel the file system as a file system check would normally take. You can also run the command called fixfilesrelabel, and it'll go clear out your temp directory. It'll delete all the xfont stuff if there's any xfont services running that are being stored. Don't do this while the system's running and run level 5. X will get really cranky and say bad things about your parentage. Reboot after it's done, and we're good to go. All right, so then you'll reboot or run set and force 1. For those Windows admins who are in the room, there is a graphical tool for doing all of this. If you install the Xorg, X11, Xauth, and fonts, you can SSH-X into a machine, install policy core utils GUI. And when you do, you'll have the command system-config-SELinux. You install it, it comes up, you run system-config SELinux, and check this out. The current mode, the default mode, what the policy is, what Booleans have been set, what file labels have been set. I can even go in and search for foo, and sure enough, hey, you remember that, wait, where'd it go? There it is. The /foo and everything underneath it? That's logged in there too. You could even set it from here. Ditto for network ports. You remember the HTTP port? We did semanage port-L. Well, you can do the same thing right here using filters. You can see about any policy modules that you created. You remember we made the Squirrel Local policy module? Well, there it is right there in the UI. So hopefully, we have done the working out. So hopefully, you don't feel like the 98-pound weakling anymore. This is not nearly as hard as it once was. So final thoughts. Don't turn it off. It really can save your bacon in the event of a breach. I have seen this happen. This is not Thomas talking theory. I have seen SELinux save a guy who had a misconfigured php.ini that let a bad guy in, and the bad guy was trying to get the Etsy shadow file. He's trying to get into the home directories. He's trying to do all kinds of ugly stuff to the machine. SELinux is like, nope. What do we say to death? Not today. All right. It's a whole lot easier to use SELinux than it was just a few years ago. And this is NSA-grade security that is available for free as part of the distribution. So if you liked today's presentation, take the pop quiz that's called Survey. The answer is 5. For all the questions, it just answers 5. If you didn't like today's presentation, just keep your opinion to yourself. For more information, you can read the SELinux User's Guide at access.redhat.com. Look at the Fedora Project SELinux documentation. Join the Fedora SELinux mailing list. It's a very low traffic mailing list with some really good information. Go read Dan Walsh's blog. Dan Walsh has forgotten more about SELinux than I'm ever going to know. Luckily, he's a really nice guy, and he's not as intimidating as you might think. So you can read that. And we are actually almost out of time, but I'll open it up to any questions. Yes, sir. Okay. Is putting it in permissive mode sort of a way because it sounds like it locks down everything? No, setting it in permissive mode, I'm sorry if I didn't make this clear. Setting it in permissive mode lets everything run, but it'll log any errors. That's what I mean. So yeah. If you enable SELinux, then you're going to basically be able to do nothing. No, that's not true. If you enable SELinux, are you saying that it's been disabled for a while? If you got a new server built and you click next, 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 SELinux is enabled. Right. If you got a new server built and you turn it off, then yes, you need to put it in permissive mode, touch.auto-relabel, and reboot. It'll relabel the file system, and then I'd probably reboot again, just to make sure that you don't get any errors in the audit log. Well, that's what I'm trying to figure out is if I'm using SELinux, if it's enforced, unless you are specifically running into errors, I wouldn't make any changes. The reason that I say that is, like, all of these things are changes that you would make if you have had an error. If you just click next, next, next on a RHEL installation, you will get a system that has SELinux enforcing. It'll be the targeted policy, and you will probably never, ever even know that it's on. Unless you do something weird, like put something in a location that it's not expecting it, or if you relabel a file system or something like that, you will probably never have to use this stuff. But at the very least, I would say please at least run it in permissive mode in your environments, in your lab environments, so that you can start looking at what those things look like. Okay? Guys, we are out of time. I'll be around, but thank you very much for coming, and if you liked it, please give me a good rating. Thank you.